everyone. Nice to see a lot of places, a lot of faces. Nice that you were here. I'm going to be recording this, so I'm assuming that everyone is comfortable with that. If anything I do you forget or miss, this video will be put in Canvas and I'll show you where to find it. But it won't appear until tomorrow evening. And the reason why I can't really do it any quicker than that is that I have to edit it, and I also have to upload it into YouTube, and everything takes time. And tomorrow I have my normal classes, so I won't be able to do it during the daytime part. I'll have to wait till I come home. So it's a kind of day, by tomorrow 5 o'clock it should be online, right? So you may have to wait a day for it. For those people who are actually listening to this video, because they're not here, this video will not be available until the day after it was made. So in their case, we're going to just have 2 days, Monday and Wednesday. So that means the videos will be due on, you'll be able to see them on Tuesday and then on Thursday. So hopefully that's not too long a wait. And I will start with a little intro to myself. As you know, I'm Scottish, assuming you know that. I started getting, hold on a second. There we go, back again. Right. I started teaching, i.e. getting paid for doing it, on August of 1980. So you do a quick calculation. I've done 42 years of teaching mathematics, and this is the start of my 43rd year. So I've been doing it a long time, still don't know what I'm doing, but I keep trying. What else about me? I do this with a lot of my classes. There are certain letters of the alphabet which I use that you might not. So let's tell you what they are. It's J, not J, and it's Z, not Z. And it was my alphabet before it was yours, so I'm right and you're wrong. Thought we'd get that out of the way. What else? Most people will tell you after a few days, they don't even notice it. It's just a funny way I talk. And so hopefully you'll be in that situation. Some of my students will tell you, because I've been told, that when they're doing their homework, they actually hear a little Scottish voice while they're doing it. So don't worry if that happens. I'm not joshing, I've been told by students that's exactly what does happen. When you stop getting me, it disappears. So it's not a permanent affliction. So far, so good. Right, now, I haven't prepared as best I should. So let me jump onto the white screen, and just so to make sure that the darn thing's working. And it's kind of sort of working, but it needs to be bent and things pushed up and things pushed down. Yeah, that's not bad. Right, so you should be looking at Math 163 online. Right. Now, this is going to be like my whiteboard, right? This is where I would, if we were in class, I'd be writing down, and this is where we'll see it. Hopefully it's clean enough and you can see what's going on. Does that seem reasonable? You can see it? Good. Right. So what we're going to do today, the first part of today, is we're going to go and look at the syllabus, tell you how the course is going to be organized, tell you the key things that you need to know. And then we're going to move on to starting our first topic, which is going to be three-dimensional coordinate system, which you may or may not know about. So I'm now going to move over. Again, hopefully this will work, but you can never be sure. And there we go. You should be looking at 163 Canvas page. Is that what you're saying? If I say a nod, I'm good. 163, right. So over here we have the syllabus. Before we do that, let me talk through a little bit more on this here. Close it up a little bit for convenience. They're really just 3 sections. Canvas is a resource, right? There is no homework here. There is no, look at funny window popped up, sorry for being distracted like that. Right, so it's basically a resource. So let's show you the kind of things that we have. If we click on this first one, do you see that guy saying recorded Zoom lectures, the first tab? If I click on that, you see it's set up. Now, it doesn't have much in it because nothing has appeared, but here is our first day. This box here will have the video. You click on it, you'll be able to see it. Right, so that's where the videos for each of the class lessons, and I've just began by, week 1, week 2, and so on. Let's return home, see what else we have. There's some information about me. Zoom resource page, in case you're having issues with Zoom. There is Officer. Because we're not physically here, you cannot come to my office, I'm assuming. But if you do turn up, it's totally fine. It's 11 o'clock and it's in well, it used to be called ST111. It's now building 8, room 111. Dead easy to find. It's straight across the way from the tutoring. So if you can find tutoring, you can find my office. But if you physically can't do it, I will have Zoom running during that 11 to 12 window, and you can just contact me by Zoom if you want to, face to face, and tell me what's going on. It tends to be a little bit easier than sending me an email, because it's quite difficult, isn't it, to send information as an email unless you do screen grabs. So that's pretty much how it's going to work. I will try. I know I didn't do it today, but I was kind of unprepared today, so much to catch up on. I will try and start a little bit earlier, so that if you come in like 15 minutes before class begins, that can be like a non-official officer where we can go over homework questions, whatever you might be doing. So that might work better for you. And I'll try my best to make sure I'm in early. I know today was an exception. There is the link that we use to get here. You must have known it because you're here. Pretty much everything you're going to do as far as assignments go is going to be on WebAssign. So let's just jump over to the syllabus and we'll come to WebAssign in a minute. Here's our class. Attendance is optional, so you didn't need to be here, so I'm glad that you turned up. It's much better for you, I think, if you're here, because I'll go over some things and you might want some clarification. Well, if you're here, can't you just ask, right? And you can, what does that mean, or how did you come up with that? That kind of question. I will be more than happy to help. Here's the officer link that we told you about. To take this class, you need to have the right prerequisite. And so the prerequisite essentially is that you did Calc 2 and got a 2.0 or better, or you did the equivalent of that in some other form. Typically, you did it some other university and it transferred, or you took a placement test and you got in here. Normally in the next couple of days, I get a list of people who do not have the prerequisites, but I would hope that everybody here has. If I do get such a letter, then I have to, I don't have the power, you have to be dropped. So as long as you're okay, right, yeah, I did Calc 2, I got a 2.3, I got a 3.2, whatever it is, you're good. This one here is just me basically saying that I need to adapt the class, then I have every right to do so. So I will move homework from one week to the next, right? I will, do whatever I feel is necessary given the circumstances. Now, you obviously need technology, like a video cam and so on, to be able to hear and see this class. So I'm assuming that that is going. I think the college will still supply some people, if they get in early, with loaner computers and webcams and whatever. So you might want to think about contacting them if you don't have it. You don't need a textbook because the textbook is in WebAssign, it's an ebook. What you do need is that code there, because that's the code that gets you into our class. That's the code that lets you get into WebAssign You need to pay for it, but when you enter WebAssign, if you do it, one of the ways you can do it is you can use up a 1 week free trial kind of thing, and then you pay for it. Or you've already bought the code, say from the bookstore, or you went to Cengage directly and got it. They're the safest places. I'd be a little bit worried if you try to do that same thing, you know, in some of the shadier parts of the internet, because you may think you're buying that code, you fork out the money, and then you try and use it, and you find out someone else has already used it, and it's no good, right? So make sure that if you buy a code to get into WebAssign, that it's a valid one. I guess they call it formally the license code. Right? Now, there is another thing that sounds like it, but this here is our class key. That means that if you use this, you will get to this class and only this class, and that's what you want. And here are the instructions and how you would do it, kind of hit and miss. These are the important dates when things are holidays, for instance. In our class, Monday is December the, whatever it is, October the 10th. Can't read more right here. That's a holiday. We have a midterm on this Monday, and it's going to last from 5 till 8. So that's a midterm. So you want to make sure that on that particular Monday that you have 3 hours to do it. I'm pretty flexible about that. If you can't make it, we'll tweak it the best way we can, but that's going to be your midterm. Friday doesn't really affect us, but it's a holiday. And of course, Thanksgiving. Wednesday is the only day that you would worry about, because the other days you won't be here anyway, right? So these are our holidays. And here is our final exam. And again, it's a 3-hour period, and it's going to be online. So try and make sure that you have a 3-hour slot on that particular day, and because we need you to be present, and I need to see you, because if we're doing an exam, I need to see that John's not got his brother next to him telling him the answers, for instance. I don't even know if John's got a brother, but I just picked on him. So let's go on a little bit further. Week 1. So basically, you've got until midnight Sunday to do them. So I guess I should say Sunday, but don't matter. We're going to be doing 12.1 and 12.2, which is to do with the 3D coordinate system and 3-dimensional vectors. And then week 2, we'll do this, and week 3 and 4 and 8 and 9, and then we'll finish with these ones. Question?
Professor,
Yes.
is there a reason why for week 1 and week 2, there's online test 2 and online test 2?
No, it's just a typo. That should say online test 1. That should say online test 2. But thanks for pointing that out. I'll try and take a little note. Fix week 1. Yeah, just a typo. Each week has a test with the number on it. So week 3 has an online test 3, right? Kind of makes sense. Now, let's talk a little bit about the homework and what you're doing. It's going to be on WebAssign, right? So if you've never done WebAssign before, though hopefully a lot of you have, I'm going to see if I can nip over and show you WebAssign. I think I've already got that loaded up. Let me check. I have, right. So when you get into WebAssign, this is an example of what you would see. Now, let me bring over another page. Are you looking at 163 WebAssign? Because when you move windows around, I don't know what Zoom does. Okay, so that's good. So I'm going to go into student view, so it looks more like what you would see. Right, so if you've got more than one WebAssign class, you would click here, and that would be our class, and you tick go. Now, what you can see here is a list of homework sections. And it looks like I've put 12.3 on that week. I probably shouldn't have, but we'll fix that later. And let's pick one. That one. Come on, there we go. And essentially you get homework questions like whatever this one is, and here's another one. And then you answer it by typing your answer in there. So you do it on paper, because a lot of these things you can't do them in your head, right? You have to do some working for a lot of them at least. And you put them in here, and then you type in your answer, and then you go to the next question, and it says which of these, and then you pick an answer like that one, let's say, and let's say that one. And if you think they're right, you hit submit answer, which would be a miracle if that was right. And both of them are wrong. And you can read about it. It's a little bit slow, but you can read about it, and it will, here we go, it's loading up. It takes you to the ebook, and there's little videos you can watch, and it, you know, you can go to the next page, and eventually, if you read through it, you'll be able to get the guide that you're interested in. If you click watch it, it gives you a video that helps you answer that question. If you do master it, it will give you some practice questions that you can look at. So WebAssign is pretty good at giving you a lot of help, right? It's not like we chuck you out and say, look, go for it, learn it yourself, right? You should be able to get a lot of things. You get 5 shots at each question, right? So if you get it wrong, technically, couldn't I pick that one and pick that one and submit my answers? I'm guessing here, I'm not making any attempt to do them properly. Oh, I've got one right. And if I pick that one and then submit my answer, yeah. Now, do you notice I got those 2 right without even reading the question or without pretending to do it? Will you not do that, right? Because when you get a midterm and the final and you maybe get a question like that, you won't know how to answer it because all you did was guess until you got whatever it was correct. Since you've got 5 guesses and there's only 3 choices, you know you're going to get it right eventually. So it's important that you kind of don't do it that way. Now, let's see if I can pick, pardon me, pick that. Right, if you click on one of the answer boxes, very often this little fella here appears. I don't know if I can move him. Can I move him? No, I can't, okay. If you want to do square roots, if you want to do fractions, if you hit this one, you can get pi and theta and infinity. If you hit this one, you get vectors. Now that is a special vector, I, j, and k. That's vectors, and this guy's vectors. So all of these things are to do with the way that we write vectors down, right? So there is a very specific way of doing it, and these are the windows. So if I wanted to do a vector, I know that question's not a vector, but if I did, I could choose this notation, and the vector might be 1, 2, 6. And boom, click off. That would be my answer as a vector, for instance. Are you kind of familiar with WebAssign? I don't really want to hang about too much on this. We good? You can practice on it until you feel comfortable, but it's there. So let me continue, if I can close enough windows. Here, we're back to the syllabus. Here are all the chapters that we're going to be covering. There's your final exam. This fella here, see if I can make it bigger. Yeah. This fella here is the learning objectives. When you finish this class, you will have been able to say, yes, we did these things. Academic honesty, do not cheat. That's the short term. Some of you may have accommodations that I need. So in case I forget what you need, you can, talk to me at the end and we'll fix it. That will not appear on the video, right? Because I edit the video, right? I cut out stuff that's only between me and you. So if I said to Natalie, I don't know, where do you live, Natalie? Because I'm nosy. That would not appear in the video, right? That's nothing to do with your class. It's just me being nosy. So if you have any issues that I need to make an accommodation for, just tell me at the end. I'll make sure I do them, and then I won't appear in the video so nobody else knows. Right, let's talk about what what you're going to get, or how your grade is going to be calculated. 25% of your grade is going to be from your homework assignments. 25% of your grade is going to be from your online tests. So every week has a test, and everything every week has to be done by midnight Sunday. Right? So let's tell you a few more details about that. Homework assignments, if you don't have enough time or you forget, that it was due and you find yourself cut out, you can ask for an extension. All you basically do is send me an email. In WebAssign, there's various buttons like ask for an extension button or talk to my professor button. Don't use them, they don't work. Just email me, I would like an extension. And what I will do is I'll give you another week to do your homework. That doesn't work for your tests. If you don't do your test by midnight Sunday, it's gone. That's it, But you can start at any time you like. It will appear every Friday. So it's not in WebAssign right now, but on Friday, the online test will appear and you can just do them Friday, Saturday, Sunday, whenever you feel like it, right? But you have to have it done by Monday. There are 10 tests, but I only count the best 8. So you can have 2 tests that you just didn't get round to or you didn't do well, and they get dropped, so they won't affect your grade. Every time you do, however, a homework on time, in other words, you do the homework and you don't ask for an extension, those points get added. In other words, there is a possibility to get 10 participation points. And those 10 participation points will be added to one of your, I'm not decided yet, I think I'll probably put it on the homework assignments. That's more participation anyway. So technically you could get 10% more than you typically get. So imagine your homework grade, you only got 80%, right? But you did them all on time. It would now become 90%, right? So, right, you participated, you've done it on time, you get the benefit. Now, if you don't do them on time and you ask for an extension, each time you do that, you don't get the point for that week. So you might get 1 or 2 knocked off because you needed time. Last thing about extensions, they don't continue forever. If you get an extension for week 1's homework, I'll give you another week. So by the end of week 2, you've got 2 sets of homework to do. If you haven't finished number 1 by the end of the 2nd week, it's gone. Whatever you've got, that's what you're getting. Right? I don't keep extending so that at week 11, you turn up and say, I need 11 extensions because I haven't done any of the homework. That's not going to cut it, right? So you get 1 week more. If you haven't done it by that 2nd week, well, that's on you, right? I've give you plenty of chances. You just didn't do it. I guess I could pause here. Any questions so far?
Are those quizzes timed?
Yes, they are, but they're timed in a very special way. You don't need to be there at 5 o'clock to do it or whatever. But the minute you click on the test, there's a counter and you have 2 hours to do it. Right? So whenever you want to start, you get 2. So the latest you could really start would be 10 p.m. on a Sunday, right? And still get it finished on time.
Thank you.
Right. Now, question.
I was just going to say, how long typically are the tests usually? Like,
They shouldn't take you 2 hours. I know that's how much time I give you, but they should take, depends on what you know and how quick you can do stuff. They should take you literally about 90 minutes. That's what I would guesstimate. When I pick questions, WebAssign tells me what the average time a student took to do that question. So it's pretty easy for me to know what 90 minutes looks like because I trust what they said. Like this question, the average student took 8 minutes or 2 minutes. So I go by that guide.
Okay, thank you.
But I give you half an hour extra because, we're not all the same, right? We're not an average person. Some of us think a bit more before they do stuff, right? So they need that wiggle room. So that's why I make it 2 hours and not 90 minutes. We good? Right. And that's just basically repeating all the stuff I've just said. When you're doing the final and the midterm, I really kind of want to see you, right? Turn up so I can make sure that John, do you have a brother that I've picked on you? Sister? Four sisters?
4 sisters, yeah.
God, you poor soul. Well, I have 6 sisters, so I beat you. But I know where you're coming from. I have 6 sisters and 3 brothers, so I'm the fourth one. Right. So back to what we got. You get your grade. You know, it's weighted the way we said at the beginning. Let's just remind you what the weighting looks like. Where the heck are you? There we are. 25%, 25%. So 50% of what your grade is going to be is doing your homework and doing the online tests. And 50% of your grade is going to be on your midterm and your final. That's a lot of work, you know, a lot of stress, I guess, put on you for those 2 things. Now, when you're doing homework, you get 5 shots in every question. When you're doing the online test or the online midterm or the online final, you do get 5, but you don't know if you're right or wrong. Right? So if you do a question, then later on you change your mind, you can write in the second question, do submit. It won't tell you. In homework, it will, right? If you put in the wrong answers like I did, then they just say cross wrong. So you get 5 shots, so you can change your mind, well, up to 5 times, right? And WebAssign will not tell you if you're correct or wrong. I have to go back and, you know, check what they do. And WebAssign is very cruel, but I'm not. So in WebAssign, if the right answer was 22 and you put in -22, and I'm pretty sure what you did was simply just arithmetic, WebAssign will give you 0 points, but I won't. I will give you points because I know that you've done it correctly. It's just a numerical mistake, right? Things like that I can fix. So that kind of makes it a little bit fairer. The midterm and the final, that's a little bit different. You do working and you upload it so I can see it. So that's a little bit different. And we'll talk about that much nearer the time. There's your grade. If you want to pass this class, you need an overall 75%. That will get you onto Calc 4 if that's where you're intending to go. If you're going for the Holy Grail, 95% will get you a 4.0. That's what the letter equivalent of that grade would look like. We have e-tutoring, right? You know, so you might want to look into that as a resource. We have on-ground tutoring. That's Nadine Hayes will probably do that, but you have to be present in the college to benefit from that. For you lot, it may well be that e-tutoring is the only thing that you've got, right? That you can do it. I've never tried it out. Has anybody here actually tried e-tutoring physically and could tell us a little bit about your experience?
Yeah, I've tried it. It's really good. They it's kind of like you just zoom in with them and then they work the problem on a whiteboard for you, or you could see their face if you want and they can kind of talk to you. So that's how it was for me anyway.
Cool. So there's a little commendation. I like the, I can't think of a better word, right? And it's totally okay. It is totally okay for homework. It is not okay for online tests, midterms, or finals for pretty obvious reasons. Agreed, right? So it's okay for revising for finals, right? So you want to revise, you look over some stuff and you say, look, I'd like to know this again or that. Totally okay with that. But once the test starts, you know, the midterm or whatever, you can't use the tutoring service. That would be considered cheating. We have study partners. Some people find that very helpful. So if you know somebody in this course or you want to get together with someone and say, hey, Calvin, how about me and you doing a little study group? And you say, hey, Tuesday at 8, I'm free. Yeah, I'm free. And you do a little Zoom thing or whatever. And you don't need to use Zoom. A lot of our students use other communication. I wish I could remember some of their names, but there's whatever suits you, right? Get together, share homework. It's helpful if you can look at someone's writing. So I'm not sure how you're going to do that, but if you can do it, it's good. See me, well, you can see me in the sense that you can do an officer. Canvas has a whole load of stuff. So let me finish this and then I'll return back to the Canvas page. Keep doing what you need to do. Come to class, I would suggest, although it's optional, and organize your time well. Usual kind of things. If you've got to Calc 3, you've probably figured out how to do that, but just reiterating it. Non-discrimination, pretty obvious, don't do it. Some of you may have to miss days for various reasons, but since this is an online class, I won't know because it's optional, right? But it's your job to catch up, right? It's your responsibility to watch the videos, figure out a way of getting ahead of this game. And well, that's probably going to be less of a problem, would you agree, in the format that we're using? But don't do it anyway, in any situation. None of you are going to get pregnant, right? Yeah, keep them away from that one. The paperwork involved is horrendous for me, so just don't do it. And then we're finished. So I said I was going to talk a little bit more about Canvas. So let's close this one off. And I have a guy here called Class Resources. So let's suppose that we are going to be doing chapter 12. So chapter 12 resources, I'll click on that. And if you click on this one, what you can see are videos done by various people on three-dimensional coordinates, equation of a sphere in 3Ds, and regions involving spheres in 3Ds. And these three, I believe, are done by Elizabeth Briggs, who's kindly let me use them. And this one here, shouldn't really be there, but it is now. I don't think that one should be there. Yeah. You can have a look at it. It's probably just my July version of this conversation. Yeah, I can't remember it. Now, what you have here is a PDF of notes that I've created. And it basically kind of takes you through some of the things that we are going to cover in 12.1. And here we have, what's it called? Power thingy, the slide thing, forgot the name of it. That guy. And it takes you through 3D. So if we keep going, there we go. All of that was to help you with 12.1. And then we've got stuff in 12.2, 12.3, 12.5. So there are videos, not necessarily, probably not me, but other people. So if we go over something and it doesn't quite make sense, you might want to have another perspective. So you might want to look at how Elizabeth Briggs teaches it or how somebody online teaches it. Because some of these are videos I found on YouTube and I thought, yeah, that's pretty good, cool way of doing it. Especially those things that have animations in them, right? Because it can be quite visual, and that's all. Any questions? Right, that are a lot to take in, but everything is in the syllabus or in Canvas or in WebAssign, right? You'll find all the things you need to know in one of those locations. So what we're going to do now is actually start our first lesson. So let me get back to the whiteboard. And the first topic that we're going to be dealing with here is going to be, what's the section called now? I've forgotten. It's 12.1, yes. And it's the 3D coordinate system. Well, let's look at 2 dimensions, because that's really what everyone here should be familiar with. So the Cartesian system essentially is a way that we can identify the location of any point in 2-dimensional space. So if I told you that that point there, A, was 2, 3, wouldn't that mean 2 along and 3 up? We agree it's baby stuff. 2-dimensional coordinate system. And starting at 141, actually, before that, don't you learn a whole lot of things like what the equations y equals x looks like when it took be a straight line like that, for instance? And wouldn't x equals 1 be a vertical line like that? And wouldn't y equals 3 be a horizontal line like that? And y equals x squared would be a big happy face going through the origin. In fact, that point there is called the origin. Right. It's a 2D world. But if you think about it, the 2D world is quite artificial. We don't live in a 2D world, don't we? Live in a 3-dimensional world. And so we need to expand the mathematics to deal with reality. So how do we have or create a consistent 3D coordinate system? Well, what we do is we add another line, and we call it the z-axis. Now, this is a flat piece of paper, so I'm going to try and describe a 3-dimensional thing using a flat piece of paper, right? So the x-axis comes out this way, and typically the y-axis comes out that way. And that's how we tend to describe or try and draw what a 3-dimensional space looks like. So I want you to think of these pens as being, that's the z-axis, this is the x, and this is the y. Can you see the 3-dimensionality of it a little bit better? Now, it's very difficult to use this practically, but we're doing it as a starting point. We're going to, in a few moments, show you that there's some nice software that makes life easy. But imagine I had a point, A, and its coordinates were 2, 3, 1. Right? Now, if you wanted to plot it on a 3-dimensional axis like that, there's the origin. 1, 2, 3 would be the positive. The y values would go 1, 2, 3, and the z ones would go 1, 2, 3, 4, 5, and so on. Now, to plot this point, the x is 2, so you go to here. The y is 3, so can you imagine me going parallel to the y-axis and doing 1, 2, 3. Can you imagine that was 3 units in that direction? And then finally, the z is 1. So what I would then do is I would go up 1 unit to there. And that's the location of A. Now, if I rub out that dotted line and that green line, wouldn't that A be just floating in space and you wouldn't really know where it was? Would you agree it's much easier in 2D to know where A is? Even if I didn't tell you that was 2, 3, you could have a fair guess that that's where it was. Right? So can you see the impracticality of trying to draw 3-dimensional things on 2D paper? But at least you've got an idea how it works. One of the things that they tend to do when they do these things is they add in some extra lines and they make a box out of the thing, like an invisible box. Can you see the location of A is in that corner there? So you see it goes 2 along, 3 along, 1 up. That's how you get A. And so you'll see some pictures where they add the box to make it more obvious where the thing is, right? Now, how would we want to do that in a real world situation where this doesn't really cut it? Well, let's show you how we do that. There is a piece of software called Geobra, which hopefully you're now looking at. Can you see it? And if I wanted to point to, what do I want? 2, 3, 1. So let's put it in here. make that 2, make that 2, make that 3, and finally, oops, make that 1. There. Now, can you see A floating in 3D space? Now, although it's not mentioned here, this axis here, let's orientate it a little bit differently, right? This is the x-axis, this is the y-axis, and this guy here is the z-axis. And you notice that they've also added the negative directions as well as the positives, right? So it doesn't just go up, it goes down. Doesn't go left, it also goes right, that kind of thing. Now, there is A. If I rotate this guy, can you see him floating? But do you get a better idea of where he is in terms of 3D space? All I'm doing is turning the shape to orientate it differently. Right, so if you wanted to draw a point in 3D space, and wouldn't it be nicer just to draw it, you know, like that in GeoBra, and then you can visualize it. So that's how I would do it in practice, rather than trying to do it on paper. Let's also introduce you to, put my little guys back in. Here's Z, here's X, here's Y. If you're wondering about this orientation as looking a little bit weird, why it's orientated that way and not, you know, some other way, it's caused by engineers. It really is. There's a thing called the right hand rule where they use their fingers and their thumb, and you ever seen the right hand rule? Right. They need the right hand rule. So orientating it this way matches the math with the reality of how engineers describe force fields. Now, in this particular case, the negative x's go up there, right? And the negative y's go along there, and the negative z's go down there. I didn't put them in the first one because the picture's pretty messy as it is. Right. Now, if you think of a room is a pretty good analogy of 3D space. The floor, for instance, which would be here, right? This is the floor, right? The floor is called the XY plane. So if I was thinking the floor of a room, think of that as your XY plane, right? That's the flat bit. Now, I have a front wall and I have a side wall, right? You've got the same thing. Now, if you wanted to do, and I'll try and shade it a little bit, if you wanted to do this wall here, right? So if you imagine this wall here that uses the Y, technically it goes below the thing, but it uses the Y and the Z axis, that's called the YZ plane. So whichever two axes make the wall or the floor, that's the name you give to it. So if I was doing this plane over here, right, this side wall here, you would call that guy the XZ plane. Does that make sense for a naming, right? The floor is called the XY plane. One of the walls is called the XZ plane, and the other wall is called the YZ plane, right? So they're kind of going like this and like this, right? See, like that. So if someone says, oh, I have a point on the XY plane, or I have a point in the XZ plane, or whatever it might be, and hopefully you'll be a little bit more aware of what that looks like. Now, here's another type of question that you might be asked. Oops. What's the projection of the point 1, 2, 3 onto, let's say, the XY plane? Now, what we're meaning by that is, can you imagine this point that we had, this guy here, right? If you project it onto the XY plane, can you imagine somebody had a light above it and they're showing it down? Where on the floor would the dot be, right? That's the projection. Now, if you imagine what that point might look like, wouldn't its projection on the XY plane be here, right? Now, what's the coordinates of that point where my finger is? Well, since you're on the XY plane, doesn't that mean your Z coordinate is 0? Right, you're on the floor. Your height is 0.
Your finger's disappearing. Yeah, there you
My
go.
finger. Okay, so if you take this point and you project it onto the XY plane, the answer that you get for its projection is 1, 2, 0. That's there. Does that make sense? If I said, here's a point in 3D space, what would its projection onto the floor, the XY plane would be? And what would be the projection?
So whenever you have projection onto an XY plane, Z would be 0, and then X, if it was X, Y, if it was X to Z, then Y would be 0 in that case too. You
Yes,
just say what the other numbers are.
and the other
Oh,
two numbers stay put. You nailed it, Eric. Yes.
cool. All right.
So let's think of that, what he just said. Here is the projection. Only this time I'm going to do it onto, let's say, the XZ plane. Now, when it's projected onto the XZ plane, which one of these three guys is going to be the 0? Because one of them's 0 and the other two stays put.
Wouldn't the Y be the 0?
Okay. Let's see if you're correct. Let's see if we can see a pattern here. When it's the XY plane, isn't the Z 0? When it's the XZ plane, won't the Y be 0? Do you see the connection here? And if the Y is 0, put 0 there, but don't the other two stay put? Because they're not changing, right? It's not bending or anything, right? And for completeness sake then, let's do the projection of the point 1, 2, 3. But let's do it onto, which one have I not done? The YZ plane. And now, just like you said, Eric, wouldn't that represent then that the X coordinate would be 0? Great. If you're projected onto the YZ plane, wouldn't that also mean that X equals 0? And if X equals 0, this guy would be 0 and the other two remain the same. So when you get some homework questions and they're talking about projecting a point onto one of these three planes, do you see how you would figure it out? Right. So the XY plane, Z is 0, the XZ plane, Y is 0, and YZ plane, X is 0. Now that's not just randomness, there is a good reason for that. Do you know the equation of the XY plane is Z equals 0? If you plotted all the points whose Z coordinate was 0, wouldn't you get the floor? Right? A 0 height would be the floor. Now, in an XZ plane, wouldn't the property be Y equals 0? So these guys are actually the equations of these planes. Now, in the 2D world, if I asked you to tell me the equation of the y-axis, I know it's slightly different, but wouldn't the equation of the y-axis be x equals 0? Would you agree that's the equation for the y-axis? What would be the equation for the x-axis in 2D space? If the equation of the y-axis is x equals 0, what would be the x-axis in 2D space? It's not meant to be a trick question. X-axis, 2D space, what's its equation?
Y equals 0?
Yeah, that's it. That's all it is. Isn't there an analogy here and here? You see, it's not quite a perfect fit, but isn't there an analogy, right? Similar concepts going on here. Right. So if you project that point onto the XY plane, there's the coordinate. If you do it to the XZ plane, here's the coordinate. If you do it to the YZ plane, here it's coordinate. One last question I'm going to do to each of these situations is I'm going to not ask you what the projection is, but I would ask you instead, how far away is it from the XY plane? So here's the point. And we're asking you, how far away is it? Right, the shortest distance from the XY plane. So it's a number I'm looking for. What number would it be? Yeah, John's got it right, 3. How far away is this point from the XZ plane? And if you look at it, can you see where the 3 is coming from? So how far away is this point from the XZ plane? This guy from the XZ plane. Can you see it? It's 2. And lastly then, how far away is this guy from the YZ plane? How far away is this point from the YZ plane? Fine, correct. So far, so good.
Are there any units attached to that, or would it just kind of be
Nah,
a
just be a number.
okay?
So it'd be 5. I guess you could say 5 units, but 5 would be fine. Now, let's do a comparison between the 2D world and the 3D world. Right, here's the 2D world. If I went and said to you, what does x equals 2 look like? I hope you would tell me it's a vertical line that passes through the x-axis at 2. Would you be comfortable with that? Right. In the 2D world, all the points that have the property that the x-coordinate is 2 generates a vertical line. But that's not what you get if you write down all the points in 3D space that have the property that x equals 2. Definitely that guy there is part of it. But what do you get? Well, what you get is called a plane. And a plane would look something like this. Can you imagine a plane, a vertical plane, 2 units in the x direction? It's hard for me to draw it, but can you imagine that plane cuts that? Since I'm horrible at drawing, let's do it on GeoBra. Let's do x equals 2. And I put a color on it, and there you go. Whoops, that's x equals 0. Let me change that to x equals 2. That's better. There we go. Can you see it passing right through the x-axis at 2? Do you see it's a vertical plane? Right? A plane is like an infinitely thin piece of paper. So that's what x equals 2 looks like. If I did y equals 2, this is what it looks like. Now, if I do x equals 2 and y equals 2 at the same time, do you see how they interact? They're not the same. In fact, x equals 2 is essentially parallel to the y-axis, isn't it? If you wanted to try and phrase it in English. And if I did, say, z equals 2, let's cut these 2 guys out of the picture. Right, actually, let's kick that point out of the picture. What do you think z equals 2 is going to look like when I hit that little circle and it will draw it? What was all the points who have the property that z is 2 and the x and y can be anything they like?
Gonna look like the roof of a house.
I would say so. Let's see if you're right. Oh, that's a horrible color. Let's put in a better color. Let's put in, oh, blue. Sounds good. Right. That should do it. Okay, z equals 2. Where's Z equals 2? Come on. Huh. Can you trust me? It should be Z equals 2, but for some reason it's not appearing. Oh, goodness. Okay, I can fix it. Right, let me take that guy. And I'm going to change this guy to Z equals 2 and see if that makes any difference at all. Well, it changed it to Z equals 0. That's nice. Does it change it to Z equals 2? There you go. Now, why on earth did that not work and this one does? Do you see the roof line above the floor? Right. And the floor, by the way, is the XY plane. So that is definitely, just like you said, 2 units above. So now let's look at, if I can remember where I put it. Here we go. Don't want that. Don't want that. Let's show you what some of those questions look like in WebAssign. So the first one is a story. Suppose you start at the origin. You move along the x-axis 9 units in the positive direction. Okay, so that would be 9. And that's in, there we go. And then you move downwards along the z-axis a distance of 8. So leave that guy blank, put in an 8. Unless I'm mistaken, they didn't mention the y-axis, did they? Let's put the answer in, see why I'm not, that's not making sense to me.
Wouldn't Y
Oh.
just be 0?
Yeah, because you're not moving, and if you're not moving, it's 0, which is what they say. That's it. And let's make all those answers go away. Right, here is a point or 3 points, and they say which one of these is closest to the YZ plane. Right? So if you're closest to the YZ plane, don't you just want to know what distance you are away from it? Right. Now, which coordinate, the X, the Y, or the Z, tells you how far away you are from the YZ plane? Now, we did earlier questions. Remember, we did the projections and then I said how far away you are? Right, this is where this kicks in. Is it the X, the Y, or the Z when you want to know how far a point is away from the YZ plane? Which one do you use?
X.
Right. So in this case, it's 4 units away. I don't care that it's negative. In this one, it's 3, and this one is 2. So doesn't that make C correct answer? So do you see how they might phrase questions slightly differently from the way I did? But there's lots of ways of looking at something. Now, in question 3, can you see they've got that projection thing that we talked about? So that's pretty straightforward. In this one here, here is the point 4, 5, 6. And they have 4 pictures, you know, the little rectangle pictures. And they're telling you that guy's 4, 5, 6. No, this one's 4, 5, 6. Maybe it's this one, or maybe it's that one. One of those 4 pictures is telling you the truth, right? And the others are not. I don't know if I can shrink this so we can see all of them. Okay. We'll call that number 1. Well, we'll call that top left, top right, bottom left, bottom right. Which one of those pictures has the arrow pointing at 4, 5, 6?
I can't see the bottom shoe, but I know it's not the top shoe.
Okay, there.
The bottom right.
So you're going for this guy here. Well, let's check it out. 4 in the X, 5 in the Y, 6. So you're going for that one, right? Now, do I have a submit? Oh, darn it, I don't have a submit button. Okay, I got a fix for that. Right, if you hold on a few seconds, I'll set it up slightly differently so I can do the WebAssign thing. Do, 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 do. Here we go. And the question that we were talking about was that one. And so I will now do submit answer. Are we good or are we good? Right? We got it. And then they throw you this curveball. Find the length of the diagonal of the box. Well, you might say, well, what is the diagonal of the box? It's the distance from one corner diagonally through the shape to the other corner. So that distance there is a diagonal. This distance from here to here is a diagonal. This distance from here to here is also a diagonal. And even though they don't look it, they're all the same length. So it doesn't really matter which one it is. Problem is, how do you find that number? How do you find the distance between 2 points in 3D space? So that brings me back to here. And we use a formula called the distance formula. And we're going to do the distance formula in 3D. So let's show you what the distance formula looks like in 2 dimensions. Imagine I have a point A with coordinates x1, y1. I have another point B with coordinates x2, y2. If I want to find the distance between them, it's the square root of x2 take away x1 squared plus y2 take away y1 squared. Can you remember that formula? I know it's one of those things you see like once every year, but does it ring some bells? Called the distance formula, right? And so the answer is going to be the square root of 9 or whatever, right? Square root of 22. Well, suppose I have a point A in 3D space. So it's going to be called x1, y1, z1. And the point B in 3D space is going to be called x2, y2, z2. The distance between the 2 points, D, is given by a formula that I'm about to write down. If the world was fair, right, and everything was nice, you should be able to have an intelligent guess for what this formula should be. Even if you've never seen it in your life before, you should be able to have a pretty good guess at what you think it should be. Any takers?
It's gonna look like the one above it, but just gonna have Z's.
So the difference in the x squared, the differences in the y squared, and the difference in the z squared. So that question that we saw a minute ago that said, find the coordinates, right, the distance of a diagonal. Remember that one? Find the length of the diagonal. I'm just going to randomly pick 2 opposite corners. So one of the corners had coordinates 2, 3, 5. And I'm going to call that guy A. And the other opposite corner was actually the origin. So the distance between the origin and that corner point is the length of the diagonal. So its distance is going to be that guy take away that guy. So 0 take away 2, right? The difference in the x's squared plus the difference in the y squared plus the difference in the x's squared. And that ends up being the square root of 4 add 9, add 25. So 25, 9, 38. And so the answer would be the square root of 38. You comfortable about that? The length of the diagonal is from one corner to the other. Right, let's return back to the homework and see if that works. Right. So I'm saying that the distance from that point there to the origin is one of the diagonals, right? And we came up with the square root of, so here we go, square root, and the number was 38. And now I'm going to do submit answer. And it's correct. Now, if you've done WebAssign before, they changed the questions on you. So the one I did had these coordinates. But John, you'll do one and the coordinates are 5, 7, 42. And Natalia, you'll get 0, 3, 59, right? So everybody's numbers are going to be different. And so you can't really phone up John and say, hey, John, what's the answer to question 3? And he'll say, well, it was the square root of 38 and I got it right. Because if Natalie puts that in, once you get it wrong, because her point's different, right? So you won't be able to do it. What you can do is you can talk her through, oh, this is how I got the answer. But these were the numbers I was using. Your numbers are different, but if you do the process, you'll be fine. We good? Right, now, the next group of questions are pretty straightforward, so let's just get them out of the way and then we'll go back to using the distance formula. In 3D space. Now, you see that R cubed, make it bigger. I need to do things so I can see them as well, right? Did I just click on something I didn't mean to? I did, didn't I? There we go. What does x equal 9 look like in R2? That just means two-dimensional space. And what does it represent in R3? That's three-dimensional space. So you notice that that's 2D and that's 3D. Right, isn't x equals 9 a line? In fact, isn't it a vertical line if you wanted more detail? But in 3D space, it's what we call a plane, right? An infinite flat piece of paper is called a plane. Any questions? Right. Now we're going to look at some, okay, I've lost my place here. Okay. There you're back again, guys. Okay. We're going to use the distance. Say again?
What does that R2 mean?
Looks like that, R2. It means 2D space. In other words, axis and y-axis. And when you do R3, that means three-dimensional space.
Okay, cool. Thank you.
Now, you could do R4, but you'd have a problem trying to draw it. Right? There's only so far the human brain can cope with. So I'm going to give you a question now that's going to use the distance formula to solve it. I'm going to give you 3 points, and they are going to be A, B, C, right? And these are 3 points in three-dimensional space. And we are going to find, and I am making no attempt to be realistic here, but can you imagine that they make a triangle, right? Which they probably would. Would you agree if you just randomly pick 3 points, you make a triangle? But same thing. The only difference is, isn't this triangle probably going to be sloping at some weird angle, right? Because it's in 3D. But here's the questions that we're going to answer. We are going to find the length of AB, which you very often will write like that. going to find the length of AC. And lastly, we're going to find the length of BC. So we are essentially going to find that length, and that length, right? Now, once I find the lengths of those three sides, right, AB, AC, and finally BC, I can then answer questions, for instance, like, is this triangle isosceles? And so the answer will be yes or no. Now, if this triangle did end up being isosceles, what would you notice about these three lengths? What would be true? If my triangle was isosceles, what
Two
would be
sides
true?
would be equal.
Correct. If I said they're equilateral, wouldn't all three sides have to be equal? So you'd say, oh yeah, they're all square root of 42, equilateral, right? Two of them are the square root of 17, the other one's 10. Oh, isosceles. What if I said to you, are these right angled? Right? Is this a right angle triangle? That's a bit trickier, isn't it? So this is the test if it's right angled, because sometimes they ask you that. You take the biggest side, whatever it is, and you square it. So it might be that one, it might be that one, it might be that one. I don't really care. Whatever the biggest one is, you square it. You take the other two, I'll call them the first one, square it, and the second one, and you square it. If these two guys squared added together is the same thing as the big guy squared, you have got a right angle triangle. An example of that might be this guy's 13, this guy's 5, and this guy's 12. Can you just pretend for a minute that was the numbers we got? If you take the big one and you square it, you get 169. Agreed? If you take the two small ones, 5 and square it, and 12 and square it, you get 25 added to 144, and you see that they match. That means right angle triangle. Okay? Now, if they were two equal, like these two were the same, wouldn't that make isosceles? If the three of them were equal, wouldn't that make it equilateral triangle? If they were all different and this wasn't true, wouldn't you just have a boring triangle with no name? Right? So you can tell what kind of triangle you're going to get in 3D space by just finding the lengths of the three. Now, this is the real one, right? This is one that I just created. My gut feeling is that it's probably going to be a boring triangle, right? It's not going to be any of the ones we talked about, but that in itself is an answer. So I'll write down the side, the guys again. Here's A, 1, 2, -3. Here's B, 0, 5, 1. Here's C, 0, 2, and 3. Okay. The length of AB uses that notation. These are absolute values, but they also, in the context of this, mean the length AB. It's going to be nothing take away 1 squared. 5 take away 2 squared. 1 take away -3, so that's 1 add 3 squared. And you will get from this one the square root of 1 add 9 add 16. So that guy is the square root of 26. I'll put a little circle around that to remind myself. Now, if you do the other two, and let's say we find AC now, let's see what you get. 1, nothing, 6, square root of 37. And if you did the third side, you're going to get nothing, 9, and 4, which is the square root of 13. Would you agree that this triangle is not isosceles? Definitely not equilateral. Can you trust me if you take that big guy squared and you do these two squared and added, they don't match, so it's not right angled. So wouldn't this triangle just be a boring old triangle, right? Nothing special about it. On the other hand, if two of these were the same, wouldn't I be able to say isosceles? If all three were the same, I'd say it was equilateral. If the old big guy, the other two squared added was the same, wouldn't I say it was right angled? Those would be totally valid. So here's a puzzle. Imagine I find, for a different set of points, the following lengths. And something weird has happened in this last example. That, in fact, is not a triangle. How do I know that the 3 points A, B, and C are actually all on the same straight line? How can you tell, just by knowing these three numbers, that this is a straight line and not one of the other triangles that we talked about? Look carefully at the numbers.
Is it because 13 plus 7 is equal to 20?
Yeah. These two add up to that guy. Isn't the only way that could happen is if they're all in the same straight line? Now, if you know a little bit about it, that would have to be A, that would have to be B, and that would have to be C. Can you see that bit there is 13? That bit there is 7, but isn't the total distance 20? Isn't that the only way those numbers would work? So not only do I know that A, B, and C are in the same straight line, don't I even know the orientation that they're likely to be, i.e. A is in the middle, for sure. So that's a special case of that example that we just looked at, that you may have a set of points and they're all on the same straight line. If you have 3 points on the same straight line, you're going to see this term mentioned. Sometimes hyphenated, sometimes not. Collinear. So any points on the same straight line are said to be collinear. Are we good? Any questions? So that one that I've just talked about would be question 6 in the homework if you're interested. Last topic for today. Quite a big one. It's the equation of a sphere in 3D space. Technically, it's the equation of the surface of the sphere. So if you bear with me for a few moments, I'm going to have to go hunting for one of the things that we need. I'm going to look for a piece of software. So let me close the windows to do that. Okay. That's me set up. Right. Let's find the equation of a sphere, center the origin. So the center of the sphere is 0, 0, 0. Now I'm really bad at drawing, But can you imagine that's a three-dimensional sphere, right? A balloon, right? Nice and spherical. The equation of a sphere is the x coordinate squared plus the y coordinate squared plus the z coordinate squared is equal to a fixed number. So if it's equal to 9, as an example, that would be a sphere, center of the origin, radius 3. Are we cool with that? So if you want to have the equation of a sphere of any given radius, don't you just make that whatever the radius is squared? So if I said to you, the center of the sphere was the origin, and the radius was 5, the equation of that sphere would be x squared plus y squared equals r squared, 25. So far, so good. Now, suppose it's not centered at the origin. Can you imagine a sphere away over here somewhere, right? So imagine its center was 1, 2, 5. And let's say the radius was 5. Like it on. The equation of the sphere will be x minus 1 squared plus y take away 2 squared plus z take away 5 squared equals the radius squared. Are you comfortable about how to find the equation of a sphere whose center is not the origin? Do you notice that the combination of these numbers and where they come from? Now, what would be the change if the center was 1, negative 2, 5? What would change here?
Be y
Be
plus
y
2.
plus 2. Oh, yeah.
So isn't it y take away the y coordinate of the center? So y take away negative 2 is plus 2. So that seems reasonable. Right, just one more for completeness. Suppose it was 3, 0, negative 3. And let's suppose the radius was 2. Good on. X take away 3 squared. You wouldn't write y take away 0 squared. You agree it's kind of clunky, wouldn't you? Just say y squared. And z add 3 squared equals 4. So if I tell you the center and the radius, are you comfortable you could do the equation of the sphere, right, the surface, based on these examples, right? Just generalize it. You feel good about that? Right, so if I tell you the center is 1, 2, 3, and the radius is 42, you could write down an equation. Let's reverse the information. Suppose I give you the equation of a sphere.
What is the purpose of finding this equation?
Well, why are we doing this? We're looking at 3D surfaces, and we're looking at, in particular, a very common one, which is a sphere. And we're trying to say, well, how would that work in 3D space? So all we're doing is really some skill building. How do you find equations of spheres? In a few, I guess, in the 3D world, don't things blow up sometimes in a spherical way? So maybe you'd be interested in what the equation on the outside surface of a, I don't know, something explodes, probably will explode in midair at least, won't it explode as a sphere?
Okay.
Now, suppose I tell you that guy, and I ask you for the coordinates of the center and its radius. So if you understand how the equation of a sphere is being created, you should be able to take this equation and tell me what the center would be and what the radius would be. Would you agree? Should be able to do that. Okay. What's the radius? It's not 100. What's the radius?
It'd be half of whatever the, well, no, I'm wrong. Never mind.
Not quite a
It'd be
half,
this,
but
it would be the square root of whatever the equation is.
So in this case, I picked numbers that come out nice. But if the numbers don't come out nice, isn't it still okay to have the square root of 22, right? Now, you should be able to get the center of the circle, right? The sphere, I should say. You agree it's at 1, 10, -2. Okay, 1, 10, -2. So far, so good. Do I need to do another one of these? Are you comfortable about how, if I give you the equation, you could tell me the center and the radius? Do you want to see another one, or are we good?
Let's do one more, please.
Yeah, sure. Let's squiggly line. Let's do an x plus 7 squared, a y minus 3 squared, plus a z squared equals 21. So let's do an ugly one, right? Where the numbers don't come out pretty. At least part of them don't. The radius is the square root of that number. Are we good? The radius is square root of 21, and can't simplify it. Now the center you get from here, from here, from here. The center would be -7 for the x coordinate, +3 for the y coordinate. And what would the z coordinate be? Agreed? Big fat zero. We're good? So if you give me a point and the radius, I can create the equation of the sphere. If you give me the equation of the sphere, can't I tell you the center and the radius, right? So one allows me to find the other, right? It's like a two-way street. We're still good? You want another one, or we feel more comfortable? Okay. Then suppose I tell you some information and I want you to create the equation of a sphere, but I'm not going to give you the nice easy stuff, right? I'm going to tell you this one. So this is similar to question 8 in the homework. Right? I'm going to tell you that the center has that coordinate and that the sphere passes through the point 7, 1, -3. Now, knowing the center is really useful. And the only thing that this tells me, or will tell me, is that won't the distance from here to here be the radius? So I know the first part, so I'm just going to write that down right away. Because that's the center, here is the major piece of the equation of the sphere. Now it's going to equal whatever the radius is squared. Now to get the radius, let's call that guy E. Won't we just find the distance from A to C, which is the distance formula? So 7 take away 5 squared, 1 take away 6 squared, -3 take away 1. Right, that's my distance formula, right? Difference in x is squared, difference in y is squared, difference in z squared. 7 take away 5 is 2 squared. That guy is -5 squared, and that guy is -4 squared. So we get 4. -5 times itself is +25, and -4 times itself is 16. So we get a square root of 45. And won't that guy there be the radius squared? So doesn't that actually come out as quite a nice number, right? Because square root of 45, if you square it, it's just 45. So there is the equation of a sphere with this center that passes through that point. Are we good? You want to see another one of them, or are you good with that? Center point. What do you want? Okay, I'll assume we're good right now. This is a version of question 10. I'm going to tell you the center. Yeah, that's the center of the sphere. I'm not going to tell you another point like I did here. What I'm going to tell you instead is that this sphere touches the XY plane. So if you wanted to imagine what that visually might look like, can you imagine that I've got a sphere somewhere over here, but the sphere touches the floor, right? It's almost like it's resting on the floor. So somehow or other, that's going to tell me what the radius is. So I know the center, so I'm going to use that right away, get it out the road. There's the easy bit done. Now, won't the radius be the distance from the center to where it hits the ground, right? Right, so the sphere is resting on the floor. That's the center. That's this guy. Well, we've actually done this before. If you take this point and you project it onto the XY plane, right? You take it and you drop it right down. Won't that distance there be 4? Does that make sense? Isn't it just the Z coordinate, right? It touches right at the bottom. And since that's 4, the answer is 60. That point is 4 units above the XY plane. If the sphere touches the XY plane, won't that make the distance from the center to there 4? So that's where that came from. I'm looking for the radius. Right, suppose I tell you then, same center, but this time it touches the YZ plane. Can you tell me what the radius would be now? That guy touches the YZ plane. So which number represents a radius?
Would it be the 1?
Correct. If you project something onto the YZ plane, isn't the answer its X coordinate? Remember we did the projections. And the X coordinate is 1. And so wouldn't this answer be the same guy, but equal to 1 squared? What would happen, just for completeness sake, if you did it and you did it on the XZ plane? What would the radius be this time? Well, here's the center. What would be the distance to the XZ plane?
Would it be the 5?
And
negative
that
5?
would- well, let's talk that through. It's the Y coordinate, agreed. And that distance technically, isn't it just 5? Because when we talk distances, it's positive numbers. And 5 squared gets me 25. So all 3 answers would use the same equation. The only difference would be the radius.
So we need to write down all of those as the general answer, or if it just, or will it just specify which plane we're supposed to find it for?
The question that I'm talking about asks you to find all 3.
Okay.
So do you want to see what the question looks like?
Yeah, I guess I would have helped earlier, but I understand it now.
Okay, so let's show you. Here it is. That's at least the version. XY plane, this plane, and find the plane. So in here, you would have to write down bracket X take away 1, close brackets, and then, you know, square it. And then the other guys, whatever they are, and then the other guy. And then you'd finish with equals 100, or equals 16, or equals 1, or equals 25. But depends on which question we were doing. The first one we were doing would be 16. Okay, so next topic, still on spheres. A lot of work on spheres, I guess, in 3D space. Spheres are kind of interesting. One is pure algebra, and one is a little bit easier. So let's do the little bit easier. Oh, I changed my mind. It's not a little bit easier after all. This one is horrible as well, but at least this one is doable. This represents the equation of a sphere. It's not, however, written in the format that we like. You know, this one here equals 16 or 1, right? You see it's quite jumbled up. And we have to recreate this using some algebra. So the first thing I'm going to do is put all the x's together. And the brackets are just for emphasis. Now, if I rewrite this equation in its standard form, that means they want you to write it like this guy here, right? With x plus or minus a number squared, same thing with the y's and z's, equals 42 or 16. Right now, it's sort of a, I don't know what that goes down there. It's sort of a getting there, but it's not really ready yet. And there's a piece of algebra that we're now going to use called completing the square. Does anybody remember the algebra trick called completing the square? Okay, here goes then. You get x because that says x squared. You half the number of x's, and then you square that number and subtract. So half the number of x's, you get 3. Put the whole thing in a square, square the 3 and subtract. So that's just the basic process for turning this guy into what's called its completed square. You see it's got an x plus 3 squared minus 9. Now, can you trust me, if you FOIL that out, you get exactly back to x squared plus 6x. Now, you want to check it out, you do. Now, second one. You get a y. Half the number of y's, square that number and subtract. Well, -1 squared is still 1, so you subtract 1. Right, the last one. Oh, looks just like that one. Half the number of z's, square it and subtract. And then all you need to do to complete the process is add 9 to both sides, add 1 to both sides, that's 10. Add another one, that's 11, and you get 25. And now I know that the center of that circle is -3, 1, 1. And I also know that the radius of that circle is 5. Kind of cool that if you give me the equation with a little bit of algebra, completing the square process, I can rewrite it in its standard form, which allows me to figure out what the center of that circle would be and also what the radius of that circle would be. Any questions about that? Okay. Last chance.
You said you have the x and then subtracted its square?
Yeah, so half the number of x's. So there used to be 6 of them. Half of them gets me 3. Square that 3 and subtract. That's where the 9 came from. So half the number of x's, square that number and subtract. Half the number of y's, that's this guy, square that number and subtract. And the same thing for that one.
Thank you.
Do you want to see another one of those? Because you'll know, yeah, okay. So let's suppose we get x squared, I'm just putting them together to save a line, plus 8x, y squared minus 4y, z squared plus 6z equals 10, right? Now, typically the x's, y's, and z would be tagged here, but I've just saved a line and put the x's together. So let's do completing the square. Cover up all the other stuff so it doesn't distract us. X squared plus 8x. Half the number of x's gets you 4. Square that number and subtract, so take away 16. You comfortable with that? Half the number of x's, square that number and subtract. Let's do the middle one now. Half the number of y's, -2. Square -2 gets you 4, so you subtract 4. So half the number of y's, square it and subtract. And last but not least, this one. Half the number of z's gets you 3. Square that number and subtract, so you subtract 9. And then get all the numbers onto the other side. And what do you get? I get 16, add 4 is 20, 29, add 29 to both sides. There you go. The center of this sphere would be -4, 2, -3, and the radius would be the square root of 39. So half the number of x's, square that number and subtract. Okay, we're almost done with this section. I've got the one I thought was easy, but now I've looked at it, it's not really easy at all. So we're not going to look at spheres anymore. We're going to look at the equation of cylinders in 3D space. Okay. A cylinder in 3D space will have this shape to it. It will look like it's a circle in 2D. Would you agree x squared plus y squared equals 9 is a circle in 2D space, right? And it's a circle radius 3. But in 3D space, what you get is called a cylinder. I would call it a tin can shape, but it's essentially that. And it looks like this. It's an infinite tin can. Now, if you looked at it from above, right, downwards, all you would see would be the circle you'd expect. But can you imagine this circle is going vertically upwards in the y-axis direction? That is a cylinder. And so there are 3 orientations. This is a cylinder that is going along the z-axis. If I did x squared plus z squared equals 9, that would also be a cylinder. But what direction would that pipe or cylinder be going? What axis would it be following?
The y-axis.
Y-axis. And for completeness sake, couldn't you also have a cylinder that looks like that guy? And that guy would be going along the x-axis. So can you imagine a cylinder is basically an infinite pipe going along the x, the y, or the z-axis? Now, if you're into 3D printing, isn't it helpful if you can do the equation of the thing that you're trying to build? So can you imagine you're trying to build this rather interesting pipe where there was an X, a Y, and a Z all meeting at the center? Wouldn't it be helpful if you could generate the surface of these shapes by an equation that's relatively simple? So I could imagine 3D printing or whatever, numerical controlled, doing that. Now, the question that I kind of avoided, I'm now going to show you because I think it's easier to see it than it is to tell you it. So you should be looking at question 11 right now. Is that correct? Is question 11, is that what you see? Right, I'm going to make it a little bit bigger. Hopefully you can read it. Here we go. Write an inequality that describes a solid cylinder that lies below z equals 9 and above the xy plane. So you can imagine what you're doing here is you're trying to give a set of instructions that would basically give you a solid pipe, right? A solid tin can, whatever it was, right, for your printer. Now, there are a couple of key things here. We are looking for the cylinder, which is the center of the origin and radius phi. So when you're looking at the equation of a cylinder, I'm going to kill that one and that one. Would you agree that these are not cylinders? Aren't these spheres? Right, so it ain't going to be those two. Now that means it's either this one, or they're tricking me and it's none of them, right? But I'm assuming that it's either this one or this one. Now, which one of these two would give you a cylinder of radius phi? The top or the side? Which one of those two would give you a cylinder radius phi? Isn't the equation x squared plus y squared equals the radius squared? Right, so if the radius is 5, it's 25. Now you might say, well, why is that less than or equal to? Why is it not just equal to 25? Because it could have been. And the reason for that is that word there. If you want a solid cylinder, that means not just the surface of the cylinder, but all the points inside it. Don't you make it less than or equal to the radius? Won't that fill the inside? Now, once I got that one, can you see XY plane has a Z of 0, Z of 9? We got it. Now that question says there's 5 options. Wouldn't you eventually guess it correctly? Because you get 5 shots. But that's the real reason of what it is. And the last couple of questions in these are actually a little bit more straightforward. One of these guys is Z equals 9. One of these is Y equals 9. Would you agree that that's Z equals 9 and that's Y equals 9? It's a little video you can watch and you can fill in some good stuff. Oh. And now I'm going to do, I want these guys all gone. So delete, delete, delete. If I typed in y equals x squared, wouldn't you get a big happy face in 2D? Wouldn't that just be a curve? Y equals x squared. But what would all the points in 3D space look like if you did y equals x squared? Well, if I orientate it a little bit better, can you see the y equals x squared happy face? And then, isn't it a curved plane? Because the z value can take any value you like. So what used to be a curve or a line in 2D, doesn't it turn into a plane in 3D very often? In this case, a curved plane. If I did x squared plus y squared, am I in the right place? No, I'm not. X squared plus y squared equals 9. Can you see you get a cylinder the way we said it would be, Infinite? Now, if I take that same guy and I add, oops, I lost my X there. And I add one more term. Can you see you get a sphere? Sphere, cylinder, curved plane. Do you see the differences in what you get in 3D compared to what it would look like if you could do it in 2D? Well, at least you could only do the first two in 2 dimensions. And I think that is going to be a natural place for us to finish today, because the last few are basically just rehashing what we've done. But there's little videos to watch, little animations and whatever, little pictures to look at and make your life hopefully a little bit easier. Any questions before we say bye-bye, guys?